Hi everybody, in this video we'll be taking a look at a soil moisture sensor and how to use it with the quantum system. So let's get started. Soil moisture sensors are used to measure the volumetric water content in soil. There are numerous ways to measure the moisture content of soil, but for this video, we'll be doing so by determining the soil's electrical resistance by using the soil moisture sensor sold by SparkFun. This sensor measures the resistance of the flow of electricity between two electrodes placed in the soil and takes that data to determine the soil moisture content. I chose this sensor because it's relatively cheap and simple to use. The only downside is that these sensors are known to corrode over time and gives less accurate readings as a result. However, I typically don't need super precise readings, so that's why I still choose to use this sensor. The sensor will have 3 pins that you will need to connect to your circuit. You have your signal pin, which will go to the GPIO terminal on your builder base, your ground terminal, and then your VCC pin, which will go to 3.3 volts on your builder base. For this video, we'll be connecting the sensor directly to the builder base, and that's going to be powered by our 5-volt DIY kit and a 9-volt battery to make it more portable. We'll be following this schematic here. So here is the soil moisture sensor created by SparkFun. Here are the 2 electrodes that will measure the electrical resistance of the soil. And then here are the 3 terminal pins that we're going to be connecting to the builder base. There is a signal, ground, and VCC that we went over. So let's go ahead and connect 3 male-to-male jumper wires to this and connect this to our builder base accordingly. So the first pin I'm going to connect is the signal pin. I'm going to use a yellow male-to-male jumper wire. The next one is the ground. So I'm going to connect the ground. And then the last pin here is the VCC. And this is going to go to the 3.3 volts on our builder base. There we go. Just check the connections here. All right, that looks good. Now let's bring in our builder base. First one I will connect is our signal pin. Since we are connecting the ground and the power on this side, we might as well use one of the GP terminals on the same side. So for the signal wire, I'm going to connect that to GP6, and then I'll tighten it down. The next one, I will connect the ground jumper wire to the ground terminal, just like that. And then lastly, I'll take the VCC pin or wire and connect that to 3.3 volts on the builder base. And there we go. Just like that. Now what we need to do is bring in our 5-volt DIY kit here, and then there's a 9-volt battery. What we are going to do is connect the 2 jumper wires that are connected to the V+ and the ground terminals on here. The V+ is going to go to 5 volts on the builder base. And then the ground is going to any ground terminal on the builder base. So let's go ahead and connect those. I'm going to start by the ground. So I'm going to pick one of these. There we go. And then next, I'm going to connect that to 5 volts. There we go. Just like that. So the reason I use the 5-volt DIY kit and the 9-volt battery is because I want to make this portable so I don't have to worry about carrying a wire all the way to a flower pot in my home just to power this on and get a reading. Also, these batteries are pretty easy to change out, so it's not that big of a deal. So now that we have our circuit created, let's go ahead and just flip the on switch for our DIY kit. Now you see our builder base is on. Let's go ahead and go to our Q server, pair it, and then do the rest of the setup. Okay, now that we're on the Q server, let's go ahead and pair that builder base. So go over to the clients tab, go to the unpaired tab. The builder base should show up here. Just go to actions, select pair. Once your client is paired, let's go ahead and click the setup button. We will name this plant 1. That way, if you decide to use multiple moisture sensors and multiple builder bases, you can distinguish them by how you name the clients. So we'll name this one plant 1, and then select office, sure. There we go. Now our builder base is paired. Let's go ahead and create the firmware for this. So to do that, let's go to the firmware tab. We're going to click create new, and we are going to name this moisture sensor. You can name this plant 1 as well if you want. And then click create. Now let's add the hardware. So we don't have a dedicated moisture sensor hardware here in the list. So what we have to use, since it's an analog device, is an analog in. So select that. Now for this hardware, let's just name this moisture sensor as well, and then click add hardware. Now let's do the configuration. For driver, we'll select GPIO. For the pin, we will select GP6, since that's how I wired it to my builder base. And then once you have done that, we'll keep the granularity at 50. Once you've done that, go ahead and click save. Now let's upload this to our builder base. Go to upload and then select plant 1 builder base and then select upload. Now while that's uploading, let's go ahead and create our application. I'm just going to cancel these or quit out of those, go to applications, and then select create new. For this, we will do moisture sensor demo and then just click create. Now this app is fairly simple. All you need to do is first bring in your hardware object. So since we are only using an analog in, there we go. Let's go ahead and name this as well. We can just name this one plant 1. That's why if you have another analog in object for another sensor as well for this program, you can name that plant 2 and so forth, or however you want to name it. For this, we'll do plant 1, click save properties. So now what's going to happen is this moisture sensor is going to use this object and send us analog data from this object, but the values are going to be between 0 and 4095. That's just how analog devices work. So we want to turn this into a percent value. That way we can measure it with percentage instead of just doing the values. So to do that, we are going to bring out the manual ranging code object. We are going to connect that analog in to the value port on the manual ranging object. And for the in minimum will be 0. In maximum, for now, what we are going to do is type in 4095, since that's going to be the max analog value. And we'll click Save Properties. We will have to change this later on, though, to get a more accurate percentage reading, because the sensor, like I mentioned before, is prone to corroding. Also, it's a resistor. Sometimes it won't get a good electrical resistive feedback from the soil. The top analog value might be different. So I'll show you how to do that later on. But for now, we'll keep at 4095. Make sure you click Save Properties. And now the out minimum we'll have at 0. And then the out maximum we will have at 100. So that's just going to scale the 0 to 4095 to 0 and 100, which is percent. And then we'll click Save Properties. For rounded, we are going to round it. So type in true or just type in 1 and it'll autofill to true. And then select Save Properties. So next, let's go ahead and bring in another code object. This is called the string merge code object. And basically what it will do is merge these 4 different string ports into one string, starting with A, then B, then C, and then D. So what we are going to do is take the value out port for manual ranging and then drag that and connect it to string A. So that's going to give us our percent value. However, we want to show that it means percent. So what we're going to do is for string B, we're going to have that input a percent sign to use for when we have this displayed on our dashboard. So go ahead and click Save Properties. Now that's done. Let's go ahead, zoom out a little bit more. Next, let's bring in our text interface object. I'm going to drag that here. And then connect that to the import on the text interface object. Now let's go ahead and name the object. This we are going to say plant 1 data. And then for the label, we'll just say plant 1 as well. Now let's go ahead and customize our dashboard a little bit as well, just so it looks nicer. So for the dash builder, our tab 1, let's just name this plant saturation levels. Click Save. Now for the group inside that tab, we will have it as plant saturation levels as well. And then, so for this object, we will add it. There we go. It's at plane saturation levels for the tab and the group. Now we'll save that. As you can see, I didn't save my properties. So this happens. So let's just do plant one data again and plant one, and then click save properties. Now, lastly, what we need to do is for the configuration for our manual ranging, we need to add in one more text object. This one will be temporary, so we'll just drag it in. And now we are going to take just the raw analog value and read that on our dashboard so we can determine what the in maximum is going to be. So to do that, we're just going to have that object. Let's name this analog value, and then we'll label it the same. There we go. We'll just keep it in the same group for now, and then click save properties. Now we'll save the app, return to my apps, we'll run it, and then make sure your plant one analog in hardware object is mapped to the plant one builder base with the moisture sensor firmware file, and then click done, and then click save and run. Once your app is running, go ahead and click the dashboard. There we go. Now we can see we have the plant one sensor with the percent value here. Then we also have our analog value to get this quick reading. Now I'm going to bring in my builder base. There we go. We have the DIY kit, and then here's our sensor. And now I'm going to bring in a cup of water. This is what we're going to use to determine what is fully saturated. It's straight water. So we'll take the sensor, and I'm just going to dip the electrodes into the water, just like that. Now you can see on our dashboard here, it says plant one has an 81% saturation level. And then the analog value is around 3,200, 3,300. So what I'm going to do is change that in max to 3,300. That way we can get closer to our plant saturation level. Go back to our application, edit it. And then for in max, I'm going to type in 3,300 and then click save properties. Now we'll save the app. I'm just going to click the play button here to run it because we already mapped our hardware. Now that's going. Click dashboard, go back to the app. Now here we have our plant one. I add the electrodes back into the water. You can see the analog value is still around the same range, but plant one, the percentage is a lot different. Now it says 97% compared to what it was before. It was 70 to 80%. So that takes us to the next demo. Let's create a quick notification system. When the saturation level gets too low, it will notify us via our LCD display as well as a Twilio SMS text message to our phone. So let's go back to the Q server, and we're going to adjust the app for that purpose. So here we are. Now the first thing I want to do is activate that Twilio service for the SMS. Make sure that's saved. So to do that, we're going to leave the edit menu of our app. We are going to library, go to services, and then we are going to download the Twilio service. If you don't know how to configure and set up the Twilio service on the Q server, I have a tutorial. I'll link that in the video description below. It's fairly quick, follow along, and then you'll have that set up in no time. Once the Twilio service is downloaded, go to the services tab, and then we are going to run the service. Now this is where I have the configured Twilio account already set up and ready to go. I'm just going to copy and paste that information to the Q server. There you go, and then click next. Now there's a telephone number tied to that Twilio account. I'm going to select that one and then select next. Now we have configured the Twilio service. So I'll select activate. Now that the service is running, we can go back to the app and then edit it accordingly. So we'll go to edit. Now let's go ahead and bring in that Twilio service. So the next thing I want to bring in is a value compare code object here. Scroll down to find it. There we go. Now what's going to happen here is when this manual ranging object sends us that percent value is going to go to the number 1 port here. And then it's going to compare that to the value 2 port. And that is the value we are going to set. If it's below that number, it's going to trigger a notification that will be sent to us through the Twilio service. So say we want it to be less than 50% saturation. That means it's too dry. We need to water it. It will vary depending on the plant you have. So keep that in mind. We'll go ahead and click Save Properties for 50 in the number 2 port. For number 1, make sure you set it to trigger and then click Save Properties for that. Now every time it's going to send out a value, it will trigger that port to do the compare. So now what's going to happen is if this number 1 value is less than 50, we are going to have that trigger our Twilio service. So we'll go ahead from the less port, take it to the trigger here. And then for the telephone number, and go ahead and type in whichever number you want to use. I'm going to type in my cell phone and then click Save Properties. Well, like I said before, I want to also have this displayed on an LCD. So the next thing we need to do is bring in an LCD hardware object. And we'll drag it over here. Now for this display, we want it to either say that everything is watered and it's fine, don't need to touch it, or it's going to tell us which specific plant needs to be watered. So to do that, we're going to have to bring in 2 static strings. So now we're going to have our 2 messages typed in. Let's go ahead and type in the first one. This one will be plants saturated. And then we'll click Save Properties. And then I'll also name it the same thing, plants saturated. Keep in mind, I'm doing this because there is a character limit on the LCD display. You can type in whatever message you want though. And for the next one, we are going to write water plant 1 exclamation point, and then click Save Properties. And then we are going to type in our message as well in the string port, water plant 1. There we go. Save Properties. Now for the SMS message, what we are going to do is when this is triggered to notify, we know it's going to be for plant 1. So we're going to have this string also connect to our SMS message. And for the telephone number, you can go ahead and type in your phone number in the value and then click Save Properties, and then you'll be good to go with the service. Now let's go back to our LCD display. The next thing we want to do is connect these 2 messages to the string port on the LCD. Now lastly, we have to bring in our data sequence code object here. The reason for this is if one message is sent to the LCD, but the characters are longer than the next message, it is going to have those older characters that weren't erased still on the LCD. It's going to look weird. So what we are going to do is have this data sequence trigger to the send to display and also clear the previous message. To do that, we are going to have it for both the less and greater port. Connect that to the trigger port of the any data sequence. And then for trigger 1, since this is a sequence, it's going to do the first trigger. Once that's complete, goes to the second one, third one, and so forth. So the first thing we want to do is clear the LCD display before the next message comes out. So we're going to go from trigger 1 to the clear port on the LCD object. And then once it clears the LCD display, we are going to have it send the message that's already stored in the string port on the LCD. This is just going to trigger the send to display command. Now we're also going to need to trigger the static string messages accordingly. So if the value of number 1 is less than 50, the plant needs to be watered. We are going to trigger this static string, and that's going to send the message of water plant 1 since this is for plant 1 analog in, and it's going to notify us via our Twilio SMS service, and then it'll also display on the LCD. If it's greater than, it's going to trigger plants are saturated, and is not going to tell us on via SMS. We don't need that, it's not important. We just want it to be displayed on the LCD that everything's good to go. So now we have our completed demo application here. We're able to read the data on our dashboard, but then we'll also be able to get notified when something needs to be watered. So now you're probably wondering why we haven't discussed about hooking up an LCD display. I've done that off camera. I have a tutorial video on how to set up the LCD if you don't know how to. But for now, we're just going to complete this by naming this LCD. Click Save Properties, save our app. Let's go return to our apps. I already have the LCD builder base paired and the firmware is already uploaded to it. So when we run this app again, we are just going to map that new LCD. Click Save and Run. Now let's go ahead and just go to our dashboard, go to that app. Now you can already see on the LCD display, it already says water plant 1. We're going to bring in our cup of water. Rearrange this a little bit better. Okay. Now when I take the sensor and then I dunk it in the water, you can see that we are getting the saturation levels, the analog value still because I didn't delete it, but then you can also see that our plants are saturated. And then also I have my phone here. Maybe you can see it. It's a blank conversation. And then when I take the moisture sensor out, it says water plant 1. You can see I got a text message here that also tells me to water plant 1. So now we have just built our own plant monitoring and notification system. It displays the status of the plant, its saturation level, and if it's too low, it'll notify us over the LCD or a text message. There you go. So I'll put it in, plants are saturated, no text message, take it out, water plant 1, I got another text message. Overall, the sensor is pretty cool. You can create quite an elaborate plant monitoring and notification system for a bunch of different plants. You can add more sensors and so forth. It's highly customizable for your needs. So I'm excited to see what you guys end up building with this. So that's pretty much how you set up and use the soil moisture sensor with the Quantum system. Make sure you check out those links in the video description below for more information about the sensor as well as everything else we have used in this video. So I hope you enjoyed this video and thanks for watching.